Right. Good afternoon, ladies and gentlemen. First of all, I want to say thanks to Zabbix team for such great opportunities speak in front of you. And unlike previous speakers, I'm not going to reveal any breakthroughs in Zabbix customization. Instead, I want to share our success story of Zabbix integration with industrial automation systems. And I believe will be interesting for some of you, so how we have put this tool to work together and in the particular monitoring requirements found in all industrial automation systems. So, my name is Yuri Suslov, and I work for Apache Corporation. So you can see a few assets where Apache presented. So I work in Egypt, in Western Desert, in the position of gas instrumentation and the control system manager. And the first question, does anyone here have previous experience with industrial automation? If you can raise your hand. Yeah, okay. All right, very nice. So that's why, in this case, some terms and terminology will be or could be confusing. So I'm not going to explain the exact difference between what SCADA means, what DCS means, and later during the presentation I will use the generic term control system. So, but some of those terms you've probably seen before on the internet or so in use or whatever. But generally speaking, and regardless of the industry, of course, a typical modern processing facility has a so-called main control room with human-machine interface screens and perhaps a couple of remote equipment rooms shown at the bottom. And every equipment room has kind of a process-specific controller wired to different types of a field transmitter and actuators. And the overall size of the system depends on the process complexity and number of control parameters. I've seen control rooms with 50 or more screens, and but at the same time it could be all in one solution, like on the left side, very small unit, probably that size, and with a small touch screen, but which does exactly the same thing. And that's how one of our plants looks like in the evening. And that's how one part of it is represented on the screen. Plant operators are responsible for ensuring the facility systems are running smoothly and maintain, making any necessary changes to optimize throughput and operating efficiency. So they use those HMI screens you have seen on the previous slide. This is just a screenshot of one of those monitors. And though the good point that all those screens are highly customizable, the engineer can bring we can make any appearance you want. Just agree on the naming convention and like color codes. Green valve means open, red means closed. The blower on the right side, green means running. And if operator need to interfere with, to make some changes, he just click on one of the special area and, he get like a kind of pop-up or any kind of, so whatever we'd give him, and he can provide set point, he can change output, can change mode. So those things are pretty standard, as I said, for to operate the plant. And again, he is also responsible for responding for process alarms, like I would say abnormal situations, generic term. And when such thing occurs, an audible alarm is generated, which draws operator attention to a particular process value. And this hierarchy is highly customizable, and poorly designed alarm hierarchy could be like could have a very bad result, actually. if you have like alarm flooding, operator can miss any critical alarm, and this may lead production loss, equipment failure, or even worse. I don't even want to talk about that. So for operators, it's easy, but what happens, or how do we report critical and non-critical maintenance-related issues? So how would look after the control system itself, because operator doesn't know all those things. So that's small example of like system status display. And as I said, the control system composed of a very large number of interconnected devices, started from field instrumentation and then through to communication devices like network switches, and finally up to the screen, up to the human-machine interface. But system alarms, because they are maintenance engineer responsibility, in most cases they are not announced in the main control room. This approach varies from site to site, but the idea behind such decision is you don't need to disturb plant personnel with the things they could not solve anyway. Fortunately, most of the DCS and SCADA components are redundant nowadays, but it's very essential for maintenance personnel to know the exact state of each device and take corrective actions before minor system problem develop in something bigger and might cause production loss, unpredictable result, or something worse. And why complex monitoring is a challenge? In ideal world, you have only one industrial automation provider or supplier for the whole plant life cycle. But as usual, so the reality is not that cherry as we could expect. Let's take a closer look. So this is a map with Apache facilities. And what we have here is 9 remote locations, 3 main control system suppliers. So those names you probably have seen, at least Honeywell and Rockwell. G stands for General Electric. So they're not making all the air conditioners, but again, big control systems. And we do have a lot of programmable logic controllers, not necessarily from those vendors, even from other one. And we have, well, sad but true, we have almost all generations of Windows. And finally, all those sites talking to each other via different communication media. And again, some strange terminology you may never seen before. WiMAX is kind of long-range Wi-Fi, up to 100 kilometers, up to 150 kilometers. And VHF is a normal walkie-talkie you use like a person-to-person communication. And I couldn't say our installation is big, comparing with other plants, but here is a number of devices we need to take care of. And what we need is something highly customizable that coordinate between different control system vendors, various device types, which talk different protocols. And what gave us all that is Zabbix. So, why Zabbix? Each vendor has some method of logging or displaying diagnostic data for their own equipment. And this information normally is available on a standalone engineering station. And as you can see here, how to say it better? In many cases, the interface of this application is not particularly user-friendly, and all of them look vastly different. So, for example, this is again another kind of diagnostic display for fire and gas controller. So some control system vendors doesn't provide you diagnostic screen at all. You have just a sequence of events and you can see only what's happening. So you have to look and visualize or to identify what's going on. And the worst case, you can have something like you have to look in the specific memory register and to find out what's going wrong with your system. Then most of PC-based, like SCADA component manufacturers, they use like a common PC-based platform. And this is an example like on a very, very obsolete SCADA system running on a Windows XP. And this doesn't provide you any diagnostic information at all. All you can see is this green LED on top, 2 green LEDs, only visual indication. There is no audible alarm or something. If you want to dig deeper, something goes wrong. You have to look inside the log with a very, very special formatted strings. And finally, so what we have is, it is necessary to monitor auxiliary machines, which are not part of SCADA or DCS, but play a significant role in customer-specific environment. And in this case, we use a special application to send files over the serial link. Or, we also have in Grafana running on top of Influx database, provide information for management. I need to know the health of those components. And, well, I would like to know who actually had all my RAM, in this case, on one of the servers. In this case, it's Kaspersky, by the way. And our simplified system architecture. So the industrial LAN shown as a single segment. Actually, it is not that. We have like a multiple firewalls in between. So, and what we have is 2 servers, Zabbix to collect numeric performance metrics, and Greylog to collect all events. And the machine sitting in the middle, OPC client. So another abbreviation, OPC. I will explain it in a second. So OPC stands for Open Platform Communication, which is a series of standards and specifications for industrial telecommunication. Originally designed in 1996, by that time was called even the very, very long, strange name, Object Linking and Embedding for Process Control. But since then, the special organization, they called OPC Foundation, was created and maintaining the standard. So the beauty of this decision is this protocol is independent of the vendor. So you know how to talk to different devices. And that's exactly what we did in here. So the in-house developed PowerShell script runs every 5 minutes as a scheduled task. We use free DLLs provided by this OPC Foundation, talk to different vendors. We get 1 JSON file per site, and with here you can see some strange names, and those names are really, as I said, vendor specific. And we create then we have parent item per each site, and finally, so we do have individual items in more or less human readable format. And once data are in Zabbix, we can create our own alarm hierarchy, and which is not reliant on the vendor-specific structure. And here is an example of a predefined set of triggers, which covers all aspects, let's say all devices on one specific site. So the operator doesn't need to call maintenance personnel anymore. And here our main screen. So maybe looks funny, but actually that's what we have. Only the most important things, only problems. So if something, this is a screen actually I'm looking 99% of the time. So you sit in the background in the Chrome browser, something happens, have an audible alarm. Oops, okay, I have a problem here. And some Zabbix health parameters on the right side. For sure, we do have some other screens, like we call them maps support screens, so which give me more details around things like communication with remote sites, but we don't use them that often, just maybe to give an overall picture. And as I said before, so control system is a mixture of the PC-based components, special purpose industrial controllers, and communication infrastructure. So we have to monitor both of them. So for example, the screens looks familiar to you. For servers, we monitoring standard things. We rely on simplified Zabbix templates, default templates, plus on the Zabbix share, there are many specific things for special manufacturers like Dell or the HP. So we adopted them for our own use. And here for servers, we use IPMI, so pulling the data in IPMI format and then format. For stations, because they don't support IPMI, we monitor almost the same: fan, temperature, power supply status, hard drive space. And here we rely on Windows management infrastructure, which is nothing very special here. You have seen all those things before. And since we heavily rely on the OPC communication between sites, the health of this OPC communication is extremely important. Here is example: we monitoring so-called non-paged pool for each process. It's not like a generic service running the node. We look deeper inside every process, and based on the previous experience of what might happen, you apply new patch from Microsoft or from vendor, and then also everything works fine in the test environment, and then all of a sudden, oops! So you have a memory leak in production environment, and Zabbix helps us to catch things like that. And we also monitoring the execution state of those Windows scheduled tasks. Every control system has a lot of devices, like a normal IT environment. So in our case, we use Cisco devices. And again, standard monitoring like traffic counters, fan, temperature, spanning tree, chain changes, port status, routing health, many things like that. And since we have more than one user with elevated privilege, we are tracking configuration changes as well. So I have a problem like that. And that's happened because user, or let's say not administrator, the engineer, logged on, made some changes on industrial switch, and forgot to click this small triangle, like load save, so Zabbix tells me that. Our Active Directory is pretty simple. We have like two domain controllers only. That's why we're monitoring on the very important parameters, like on daily basis. Zabbix initiates replication health report and checks so how many servers are healthy and tells me if something is wrong. And as you know, for domain infrastructure, it's very important to have all devices synchronized. That's why we're monitoring synchronization with external. We have two NTP sources, GPS NTP sources, balancing between them and monitoring the status of each device. For sure, we have backup infrastructure, and this is probably the only one place where we use a low-level discovery. Because the beauty of industrial automation, once you have a predefined number of devices, they're not changing very often. But in the backup is a little bit different. So every new device automatically discovered, something goes wrong, it tells me, yes, you have an error. And then I have to look inside and say, okay, yes, that was a problem creating a snapshot in this particular case. And here is a real life example. If you look on the left side, screenshot taken in December last year. So I was on shift, and that's happened in the evening when I was there. So without Zabbix, I have to log on at least to 4 different machines using remote desktop or VNC. And instead of that, and to find out the information like that. Bottom lines tells me I have a problem with the power supply on one of my gateways. So then I have a problem of data transfer between sites. And finally, for some reason, I have unexpected change of server mastership. And again, instead of looking without Zabbix, I have to have many screens at the same time. So Zabbix gives me everything on one single screen. dig deeper. So what we have, some common fault. Don't look at those abbreviations. I'm not going to explain them anymore, too many. So, but what's happened? Common fault. And what we decided, instead of create trigger for every single item, what you can see before, we just make a generic problem. So since you have to look there anyway, it tells you, okay, common fault. In this case, it tells you either the weak battery or it's application fault, and you have to look there anyway. So another example, you have a problem with redundancy. So we have every controller, in most cases, controllers are redundant. So again, Zabbix tell me, hey, you have a problem. You have to, again, log on to special place and see what's going on in here. And this is a very special case. We have to report production data to state authorities. And as I mentioned, we're in Western Desert, so 500 kilometers from Cairo, from the capital. And the only way of communication is mobile network. And some devices of those mobile network, they are so obsolete, they don't support any diagnostic protocol. There is no SMNP, there is no telnet, nothing. All they have is just built-in web server, with a very special way, go-ahead web server, and like fixed pages, nothing else. So what Zabbix does is we run an external script, parse this web page, get information, bytes sent and received, and this helps me to identify if data frozen or not. What else we are monitoring? Normally, operator doesn't have any, like I have a very basic privileges, because all he needs is changing set point or output or mode. Sometimes you need elevated privilege, like supervisor, and every time supervisor logged on via smart card or the password, so I get a notification. So as I said, time sync, we have a centralized Graylog server to store all the logs, which is very important. So something happens, I have to trace back logs from different devices in single place. So serial ports are still used in heavily used in industrial automation, but modern computers doesn't have those COM ports anymore. That's why we use USB to serial converters, which not always reliable, I would say. That's why I need to monitor the health of those controllers. So some SCADA system use SQL Express, and we have to watch the database size. That's just not to cross the 10 gigabyte limit. And so last but not least important, we have to monitor the status of power supplies, fans, temperature for every cabinet or enclosure, if you wish, at every site. And we have, to be honest, we have hundreds of them. I could not even tell you the exact count. Oil and gas production wells around each site, connected via what I called long-range Wi-Fi. What I need to know is communication status for each well. And again, because we're in Western Desert, there are no permanent line power lines. We rely on the solar power, charging during the day, as you can see, and discharge during night. And if something happens there, so if not enough, so not charged, the battery not charged enough, then the well may trip and cause production loss. Then we have to monitor. They have to watch after that. And again, day temperature may raise the 50, 60 degrees. We have to monitor the temperature inside enclosures as well. Another great feature, which I personally like, consolidated reporting. We use another PowerShell script that runs on daily basis. We use Zabbix API to pull graphs from all the sites for every well, all sites, maybe 5, 6, 7 pages. It depends on how many wells in production. Consolidate them in one PDF report, and this report email to our telecom department. every morning, and they can see, okay, so this is the problem with it. Maybe sometimes they need to reposition antenna, or for some reason was a power problem, or whatever happens. So they have a report on everything, on every site on a single page. And finally, I've mentioned about Greylog server. What we have, Zabbix is watching after another important service, as I said. Here is an example of Greylog dashboard used by our alarm rationalization team. It tells me the number of abnormal process situation and process events during last 24 hours or last hour, and then who is actually giving those process alarms. And the 0 on the right side looks suspicious because, well, in ideal world, yes, you don't have any process alarms, but you know, that's never happened. And that 0 for me means, okay, something is wrong. So what Zabbix does, it looks directly inside the Elasticsearch database, what verify how many events collected over last 2 hours. And so if something wrong, he said, okay, yeah, I have to have a look. What's wrong with that? It's either communication problem, or it's a problem with Elastic, or it's a problem with the SQL database. So, but this is another way of what we can see here. For sure, there are many other things to monitor, but we are running out of time. And but I hope the idea is clear. So, what, with the help of Zabbix, I can see. I can have the overall health of all my control system, what you call them, my fingertips. And that's it for now. So if you have questions or specific questions, so please get in touch with me, and we'll be happy to reply. And well, thanks for your attention. Thank you. Yeah, sure.
So first of all, thank you very much. I like I don't know how to translate properly, but I like when people doing this, I would say infrastructure monitoring, but as you said, with this PLC stuff, with this SCADA stuff, so if it's not just hard disk drive and processor usage in a classic sense, but if it's really an industrial environment. So I like this very much. We did also some consultancy jobs in this area, and great integration so far. When and how did you make the choice to actually pass over metrics, trigger alerts, etc., from the existing environment to Zabbix? So I would be interested into. So first of all, how did you make the choice, and how do you make the choice to use Zabbix for that?
So you mean why we choose Zabbix for that, or?
Yeah. So up on a certain point, you figured out and said, well, that is very difficult to follow, and you explained very well and hard to read. You say there must be some umbrella over the top that gives us the information in a much better way. And that is what Zabbix finally did, as we have seen here. And I would be interested in when did you make that choice, and why did you make the choice to use Zabbix for that?
Well, that's exactly what I mentioned before. So in normally, so like for this, if you have small plant, so you choose industrial automation provider, like, I don't know, Rockwell or Honeywell. And then, so from the very beginning, you have an upgrade or something else, and you grow up, but you still have that, you know exactly where to look at. So like a diagnostic screen of the certain type, you look inside, so you know you can have like a one remote desktop or engineering station, and that's all you need. And before that job, for 12 years, I worked for another company, again for Honeywell company, and we had the only one automation provider was Honeywell. It was very easy. I can have 2 screens, and that's it. It covers everything. Once I joined that, so I look at that, okay, unbelievable. That's what I said. So 9 sites and everything. So how to look at that? Every morning you have to spend, well, half an hour. So log on here, log on there, and verify. So that was, well, it is technically possible, but you know, so we are very lazy. Instead of that, for me, it's quite easy. Just drinking coffee and say, okay, boom, okay. So sound alarm, okay, not important. I will look after lunch, kind of that.
And how did you make then the choice to use Zabbix? Have you been? So what was the reason for that?
Because of it is possible, because of the way it supports different ways of communication. So we have IPMI, SMNP, because of the variety of protocols Zabbix supports. That was the main thing, and customization as well. So that's the main thing. Yeah. Okay. Thank you. Thank you.